Okay, here's something that you all need to know. And by know it, I mean you need to be able to prove it. You need to be able to prove this. And you need to be able to apply it when you need it. Okay? Like in some of these problems, it just pops up. I'm going to prove it for you here. I'm going to prove it for you here, and we'll talk about it a little bit. And then I think it would be good exercise for you to prove it on your own about 7 times. Okay? Maybe 8, maybe 10 times. And then hopefully you won't forget it. But this is used all the time. Okay, you ready? Let a be a real number. Then if I sum up, a to the 0 plus a to the first plus a to the second and so forth up to a to the n, the result is this. Okay, let's prove this. First of all, just to make things a little easier, I'm gonna set s sub n equal to this sum. K equals 0 up to n of a to the k. All right, you can think of maybe s for sum, and I'm summing up all the terms up to the one where you take a to the nth. Okay, it's really the the first n plus 1 terms, but whatever. Okay, so note 2 things. Here are the observations that you ought to make. One is that s sub n plus 1, of course, can be written as s sub n plus a to the n plus 1. Okay, that should be pretty obvious. You can stop the video there and think about it, but all the first n plus 1 terms of this are equal to the first n plus 1 terms of that. This is only different because it has this extra term on it. The other observation is that if I take s sub n, if I take 1 plus s sub n times a, I get s sub n plus 1. See that? If I go through here, if I multiply this sum through by the letter a, what do you get? You get, well, your first term is going to be a times a to the 0, which is a. Your last term is going to be a times a to the n, which is a to the n plus 1. So I add 1 to that, then I get this new sum. So now I can use these 2 things. I can set this stuff equal to this stuff, right? Here's an expression for Sn plus 1. Here's an expression for S sub n plus 1. So these things imply that 1 plus S sub n times A must be equal to S sub n plus A to the n plus 1, right? Okay. But then this means, let me pull my Sn stuff over to the left-hand side. I get Sn times A minus S sub n equals negative 1 plus A to the n plus 1. Okay, but then this implies that I could say S sub n times A minus 1 equals negative 1 plus A to the n plus 1. If I divide through by A minus 1, I get S sub n is negative 1 plus A to the n plus 1 over A minus 1, or dividing the top and the bottom, or multiplying the top and bottom by negative 1, I see that S sub n is in fact 1 minus A to the n plus 1 over 1 minus A, and we're done. Okay, that's very, very useful for simplifying sums. Also, note, as a little corollary, that as n goes to infinity, we get that this sum k, n, and k, this, right, as n goes to infinity, this thing is approaching, well, what? 1 minus a to the something big, something big over 1 minus a. So if a is super big, like 2, okay, 2 raised to a big power is really, really big, and I get 1 minus something really big, which is negative big. Okay, this is constant. This thing diverges. Okay, so this thing diverges unless the absolute value of A is less than 1. Okay. In this case, then note that that sum, if the absolute value of A is less than 1, this is just going to be 1 over 1 minus A. Okay.